the first lecture we talked about why we need statistics, and in the second lecture we talked about confounding, right? The effect of confounding. So in today's lecture we are going to study few other terms from your syllabus. So the terms that we need to study are bias, then what is a controlled experiment or control group.
Ma'am, are you presenting your screen?
Not yet, I'll present in a minute. Then comparison of controlled experiment and observational study. And we also need to talk about basically what comparison means and when things are comparable, when things are not comparable. Okay, and I think there is one more term. Let me check your syllabus once. Yeah, precision. So study design and precision. So first of all we will talk about what is meant by bias. So when you hear the word bias, what comes to your mind? When you hear the word bias, what comes
That
to
there
your
is a
mind?
preference for one thing and
Correct.
over other
I'm
things.
favoring one thing more.
Preference for one thing over other. Okay. Anything else?
Favoring a
Favoring.
person or a thing.
Favoring a person or a thing. Okay. So yes, bias has that meaning. So there are in statistics also there are multiple places where this word bias can be used. So first place where this word comes in picture is in sampling. Okay. So suppose you are trying to get information about say average height and weight of people living in Pune. Okay. Uh, First of all, what do I mean by sampling? So generally in statistics we have to do some inference about a population, but that population would be very big. For example, if I want to talk about say as I said average height of residents of Pune and average weight of residents of Pune, then the entire city is so big that you cannot go and record height and weight of each individual person, right? It's practically impossible. You have very limited time. Even if you get many volunteers, still there are going to be a lot of mistakes. Okay. So in general also whenever you want to conduct any study, most of the times your population is too large and you cannot really carry out study on that entire population. Secondly, sometimes your
I
study
don't know how you guys drink lassi.
is someone saying something?
No, ma'am.
Yeah. Secondly, the study actually may be destructive in some sense. So in that case also you cannot go for entire sample. What do I mean by that? Suppose you own a manufacturing plant and you are manufacturing say light bulbs. Okay. And you want to estimate life of your light bulbs. Okay. You want to estimate life of your light bulbs. Then the only way to figure out life of a light bulb is you switch on the light bulb, let it burn for whatever its lifetime is, say 1000 hours, 10,000 hours, whatever, and then after that period you get the estimate of lifetime. So if you own a factory and if you want an estimate of lifetime of the light bulbs, you cannot really put all the light bulbs on and then check the lifetime, because once it dies it becomes useless. You cannot sell it, right? You might have heard the joke in childhood that a mother sends a child to buy a matchbox. Okay. And the child goes there to the shop and mother has warned him, get a good matchbox. Okay, we don't want one where the matches uh, don't get lighted easily. So the child goes, purchases the box, tries actually lighting each and every match. It works, and then he comes home happily saying that this is the matchbox, and the mother is irritated because every match is used. And he says, because you asked me to make sure that they are working, so I tried them. Okay, so this is known as destructive studies, where when you want to try out something, when you want to do quality check or quality type of inspection, that inspection itself is going to cause failure of that object, or it's going to render that object as useless. So in such scenarios, you cannot really use your entire population. So as I said, either your population is too large, or your population may be small, manageable, but because of such problems you cannot use entire population. So what statistics says is, draw a random sample. Okay, draw a random sample and do whatever you want to do with that random sample. So for example, if I have a matchbox and I want to test its quality, maybe take out 3 or 5 matches randomly, check if they are lighting or not. If they are getting lighted easily, fine, then rest we have to assume that the rest are also going to be okay. Now there are many problems with this approach. I mean, not with approach, but there are many precautions that one needs to take while doing this, but that's not part of our syllabus. But where does this bias come in that sampling thing? So there are two possibilities: either your sample itself is biased, or there is another thing called as non-response bias. Okay, so let me first talk about the non-response bias, because that's why I started this story. So suppose you want to have estimate of average height and average weight of all the people living in Pune. Now, because it is practically impossible to record height and weight of every person, what you do is you take you contact say 100 people randomly, and you ask each one of them, what is your height, what is your weight, and you record it. Okay, you are not measuring, you are just asking them. Okay, remember this, you are not recording the height and weight on your own, you are just asking them. Then some people may say that I don't know my current weight, right? So who are more likely to say that I don't know my current weight? Yes, any ideas? Am I still connected?
Ma'am, can you please repeat your question?
You are asking weight, you are going to 100 different people and you are asking each one of them, please tell me what is your current weight, please tell me what is your height. Some people refuse to reveal their weight. So who would be the people who would refuse to reveal their weight?
Who are insecure about their weight?
Who are insecure about their weight in some sense. So either they are overweight or they are underweight. Generally, people who have average weight compared to their height would not have much problem with their weight, right? So as a result, what happens is, when I take say average as an estimate of my entire population, my average is going to be biased. Okay, biased in the sense there is going to be a systematic error, because all the missing values would either be too high or too low. Okay, in fact, in the case of weight, majority of them would be too high. The missing values would be too high, so I will be losing out on large observations in my data, and as a result my estimate would be an underestimate of the actual average weight of the entire population. Are you getting what I am saying?
Yes, ma'am.
So this is known as a bias of non-response, because people chose not to respond. That created a problem, and my final answer got underestimated, so it is systematically smaller than the expected answer. So this is known as problem of non-response. There is another type of bias. If my sample itself is not representative, then I might end up having a biased answer to the question. Okay, there is a very famous story about this. So you might be, see, there were elections recently, so you might have heard of exit polls and opinion polls, right? So exit polls and opinion polls try to predict winner of the election by collecting some data from people. So they conduct surveys, they ask people whom are you going to vote, and on the basis of those answers they do some calculations and they try to predict which party is going to come in power. Okay, so in our case, in the case of India, things are slightly complicated because we have too many seats, too many parties and all. But in the USA presidential election, generally there are only two major candidates, one from Republican, one from Democrat. So the answer final president is going to be either one of these two. So the count of two is generally fixed. Okay, out of these two, someone is going to become president. So this is a story from early 20th century, and there was you might have heard this name in history. Truman was president of USA for some time. You might have heard this name in history. So there is a picture, there is a famous picture, you can Google and you will get Dewey defeats Truman. That is a news headline. So what happened is, this Truman was contesting the election and his opponent, his main opponent was Dewey. Okay, Dewey is another person, and the competition was among between only these two people. Others were anyway not that important. And in those days, technology was not that advanced. Transportation facilities were not that advanced, and as a result, what would happen is, if you want to read a newspaper today, the newspaper has to be printed at least 24 hours in advance, because otherwise it won't reach you. Okay, nowadays what happens is, the newspapers report even those news, even news about things which happened late night. But in those days, printing technology as well as transportation technology was not that well developed. So the newspaper offices would print and bundle the newspapers well in advance to make sure that they reach all the remote places in time. Okay, and suppose tomorrow is the day of result of elections. So if tomorrow election results are going to be out, I want all my readers to be able to read the election result in the newspaper day after tomorrow. So today is what? Wednesday, right? So if Thursday is going to be the day of election results, then Friday's newspaper, I want the election results to be displayed, because otherwise people won't purchase my newspaper. Now the problem is, the results are going to be out tomorrow evening at 5 o'clock, and I cannot wait for printing till 5 o'clock tomorrow, because otherwise my newspaper won't reach people on Friday morning. It will be Saturday morning. So what I have to do is, by tonight I need to have my newspapers printed so that tomorrow they'll travel in trains and something, and then they'll reach the readers on Friday. Are you getting the situation? So what this there is one big newspaper. So what they did was, the editor felt that okay, we need to print the results, but we don't know the results in advance, so what can be done? So he caught hold of one cephalogist. So what's a cephalogist? Cephalogist is a person who studies elections. Okay, so he caught hold of one cephalogist who had predicted election results for 4-5 earlier elections quite well. So this cephalogist was known to have good predictions, good insights into the elections and politics. So the newspaper editor called up this cephalogist and he told him that he asked him, so what is your prediction? Who is going to be the winner? The cephalogist says, Dewey. I have done my surveys and I have completed my studies, and I am very sure that Dewey is going to defeat Truman, and not by a very small margin. The margin is quite good enough, so you can be very sure that my predictions are correct. So what this newspaper editor did was, he actually printed that as headline, Dewey defeats Truman, in a hope that that would actually happen, and he sent out the newspapers. And when the actual results came Thursday evening, Thursday means I'm just giving an example, then the situation was completely reversed. Okay, Truman had defeated Dewey, and not by a small margin, again by a considerable margin. Okay, so the cephalogist, of course the newspaper editor panicked, probably lost his job, I don't know. The cephalogist also panicked. My results have been consistent since last 3-4 elections. How come suddenly my predictions went so wrong? And then, when the analysis was done later, what he realized was that in the earlier election, what he used to do was he used to employ some volunteers who would who would visit homes of different people and get their opinion on whom they are going to vote. And he used to select the sample randomly. Okay. Whereas what he did in that particular election was he had recently got a telephone in his home, and he was, whenever you purchase a new thing, you want to use that thing everywhere. So he thought, I have got this shiny brand new telephone in my home, why not use it? So, and along with the telephone he got directory. I don't know how many of you know what a directory is, but in the era of landline we used to have something called as directory, which would have phone numbers of all the people living in your city, of course those people who own telephone. So he got hold of directory and he picked some people randomly from that directory. He called them up sitting comfortably at his home, and he asked them, whom are you going to vote? Are you going to vote for Dewey or are you going to vote for Truman? They gave him some answer. He wrote down that answer, and that way he completed all the survey forms and he did his analysis and he got the result that Dewey is going to be the winner. So what the problem was? See, this is a cephalogist. He's a very well-educated person, in the probably in the upper middle class. In fact, maybe not even just upper middle class, probably the upper class, very high socio-economic status. He has got telephone recently. So all the other people who had got telephone by then, all of them came from the upper stratum of the society. So when he called them up, what he got was opinion of one particular chunk of the society, one particular socio-economic stratum of the society, which was all upper class people. Whereas we know that in any society, proportion of upper class people is comparatively very low. The middle class people and the lower income people, they all were in support of Truman, but unfortunately, because this person's sample was biased, okay, see the word, the sample was biased, he could not get the correct result, he got biased result. What he got was opinion of only one group of society, which was not representative enough. Okay, and as a result his conclusions turned out to be completely bad. So we have to make sure that our sample is not biased, and if people are not responding, if we have missing values, then also we have to make sure that these missing values are not causing any bias. So bias is basically a systematic error in one direction. So either we get an overestimate of something or we get an underestimate of something. Normally our errors are supposed to be random, but in the biased case our errors are in one direction. Okay. Another term that we need to know is precision. So what is a precision? So precision is, there are two things, precision and accuracy. So whether an observation is accurate or not can be decided by the bias. In fact, sometimes even the instruments can be biased. Okay. So measuring instrument like say weighing scale or thermometer, all these need calibration. So if the calibration is not right, then the readings can be biased. So when you say readings are biased, the error is in one direction. Okay, so for example, a weighing scale may consistently overestimate the weight by say 500 grams, or a thermometer may consistently underestimate the temperature by 1 degree Celsius. So such things are known as bias. So the readings are not accurate, they are biased. But what is precision? Precision is consistency of readings. Okay, so if I use a thermometer to check temperature 2 or 3 times immediately, I should get more or less the same readings. Whether the readings are correct or wrong, it's a different story. Okay, so the accuracy is different, but even if the readings are wrong, at least they should match with each other. Means if the thermometer is saying that the your body temperature is say 36 degrees now, then after 1 minute it shouldn't suddenly say it is 38 degrees. It could be 36.05 or it could be 36.1. That much is fine. but it cannot say it is 34 or 38. Okay, so this becomes precision. So precision is agreement within the observations. Okay, so the observations should match. That is known as precision. Accuracy is a different story. So it is possible that your instrument is precise but not accurate. So the readings agree with each other, but they are not in agreement with the actual value. That is possible. Now control group. In the experiment of that which was the bird that we talked about, widow bird, right? Long tailed widow bird. So in the experiment of long tailed widow bird, we saw what is meant by control group. So generally control group is the group where you don't vary the existing conditions at all, and you compare the results of new things with that control group. So in their case, in the experiment of that widow bird, the birds which had normal tail length, they were in the control group. Okay, and birds which had shortened or super long tails, they were in what is known as treatment group. So what is a treatment group? Treatment group is the one where you do some changes and then you try to compare the readings from, then you try to compare the observations from treatment group with those from the control group. Controlled experiment and observational studies, let me keep it aside for a moment. Then comparison is important. So the comparison has to be on the same level playing field. Okay, what do I mean by level playing field? First of all, we should remove all the confounding effects. We did discuss what is meant by confounding variable, right? So we should remove all those confounding effects. So the groups, the control group and treatment groups should be otherwise comparable. Okay, they should otherwise be comparable. The only difference should be whether they are receiving treatment or not. So in this context, I like to tell you the story of polio vaccine. Okay, nowadays everyone receives polio vaccine, but there was a time when vaccines were not developed, and then when a scientist developed them, I think Jonas Salk. So people wanted to first examine the efficacy of that vaccine, okay, and see whether the vaccine is working or not. Now there are a lot of possibilities. First is you choose, I mean, the vaccine was developed around I think 1953 or something. So you could give vaccine to say many people in 1953 and then compare what happened in 1954. So in 1953, suppose you had say 50,000 polio cases in the, this was in US. So suppose you had 50,000 polio cases in 1953 and then suppose you had 20,000 polio cases in 1954, then can you conclude that it is the effect of vaccine? Yes, what do you think? If suppose I gave vaccine not to everyone or maybe to everyone in 1953, everyone means children, of course, and if my drop, I mean if there is a sudden drop in the rate of polio occurrence, can I conclude that the vaccine has been effective?
Yes.
Yes, okay. What about others? Does anyone disagree with her? Okay, no one disagrees with her? Fine. See, there is some problem. Polio is like epidemic kind of disease. So, if someone gets polio and if you are in touch with that, I mean, if you are in close proximity with that person, you are more likely to get it. Okay. So, if there is no epidemic in 1954, then otherwise would also cases reduce instead of the effect of vaccine. So we have to make sure that the reduction is purely due to the effect of the vaccine. If we do that, then only we can make sure that the vaccine is making the progress. Okay. So first thing is you cannot compare readings from one year to readings from other year directly, because in general epidemics have seasonal patterns. Okay, so for example, COVID cases in 2020 and COVID cases in 2021, they are not directly comparable. There was a wave at some point, at other points there was no wave, so the case number of cases is definitely going to be different. So now next option is what? So this direct comparison is ruled out. So what we have to do is, we have to deliberately leave some children unvaccinated. Okay, so we have to take one group of children, vaccinate them, you take other group of children, you don't vaccinate them, and then you compare in the next year, out of the two groups, in both the groups, how many people get polio. In the vaccinated group, how many people get polio, and in the non vaccinated group, how many people get polio. Okay, does this seem like a reasonable strategy? Does this seem like a reasonable strategy, or is there any problem with it? Yes? Am I connected? Yes, I am connected. Okay. So, this is a reasonable strategy provided that the two groups do not have anything else to cause the difference. Okay. So, this is what was tried. Now, how to form two groups? So, there was one study called as NFIP. So, this is National Foundation for Infantile Paralysis, something like that. So, what they did was, they knew that children from classes 1, 2, and 3, so grade means class or standard. So, children from grade 1 to 3 are more likely to get affected by polio. So, what they did was, they took large samples of children, school going children in these grades. Then grades 1 and 3 they kept as control. Okay, so control means they decided in advance that they are not going to vaccinate any child who is in grade 1 or grade 3, at least in that particular year. In grade 2, they decided that okay, they'll carry out vaccination, but there were two issues. Vaccination is something you cannot do compulsorily. You need consent from that patient. Here the patient are children, so you need basically consent from their parents. So some parents consented, some parents did not consent. So in grade 2 there were two groups. So those children whose parents consented were given the vaccine. So 2,25,000 people received the vaccine, and the remaining children whose parents did not consent, they were not given the vaccine. Okay. And now we have to come. So these rates are actually rates of incidence of polio in, I think, per million population or something like that in the next year. So it seems that in grade 1 and 3 the rate of occurrence is high, whereas in the vaccine group it is lowest, and in the no consent group it is moderate. So it seems that the vaccine is effective. However, there are still issues with this grouping. First issue is, when I leave grade 1 and 3 as control and grade 2 as vaccine or no vaccine, no consent group, the problem is, as I said, polio spreads through contact. So if someone from grade 1 and 3 has caught polio, then of course other kids from the same grades are more likely to get polio than kids from grade 2. Correct? If someone in your class gets a disease, then others from the same class are more likely to get that disease. So that's why keeping different grades as treatment group and control group is not valid in a case where your disease is contagious. Okay? Is it okay? This was first thing. Now secondly, even in the suppose if I ignore this, okay, suppose I decide that I'm going to ignore this group, grade 1 and 3. I'll focus only on grade 2. Now in grade 2 I have two groups, one which consented to vaccine and hence received the vaccine, whereas others who did not consent to vaccine and hence did not receive the vaccine. Then I can compare among those, and then you will say that yes, see, here also things are okay. Here also things look okay, fortunately, because vaccine was very strong. I mean, vaccine had very strong good effect, but still there is a problem. Why? Because even in this consent and non-consent group, these groups are not homogeneous. What do I mean by not homogeneous? Generally generally people who are having a stable income, people who are educated, they would be open for vaccination, whereas uneducated people and who have less stable income, who are poor, they may not consent to vaccine because they may not realize the seriousness of the vaccine. So this group, vaccine group, is likely to have come from an upper socioeconomic status, whereas this group is more likely to have come from a lower socioeconomic group. Of course, I am not saying that every person in this group has come from high income family and every person in this group has come from low income family. That's not the case. But the proportion of high income people is going to be high here, and proportion of low income families is going to be high in this group. Now, why does income matter in the case of polio? In fact, it matters in a reverse way. Reverse way means normally what we think is, people who live in non hygienic conditions are likely to get diseases. That's our normal assumption. But in the case of this serious polio, there is a reverse scenario. Why reverse scenario? Because those who live in non hygienic conditions, they are likely to have caught the mild version of the virus in the earlier years of their childhood, and as a result they are automatically vaccinated. Okay, they have already got the antibodies, and hence they are less likely to develop the serious polio complications from polio in the next in their future life. Whereas those who live in a very sanitized hygienic environment, they would have no prior exposure to the even the other strains of the virus, and hence they are more likely to get serious complicated disease from the one if they get exposed to virus. Okay, so kids from upper socioeconomic stratum are more likely to have, I mean, they are more susceptible to polio, and they are more likely to receive vaccine. As a result, our results may be biased against vaccine. And now if you go to this study, which was considered, I mean, which was designed more seriously, then you can see that that is actually happening. So in this study, we can see that in the treatment group, rate of incidence is 28, whereas in control group, which was similar and same in size, the rate is 71. So the occurrence of polio is more than twice, I mean, even 2.5 times more likely without the vaccine. Whereas here the evidence is not that strong. It is 25 versus 54, and in fact, if I ignore the grade factor because of the reasons that we discussed, it is 25 and 44. So the evidence in favor of vaccine here is not that strong, whereas in this properly designed study, evidence in the favor of vaccine is quite strong. Okay, so how did they decide this? So here what they did was, they asked people for consent, and even among those who consented, they did not give vaccine to everyone. They chose randomly. So for every kid whose parents consented, they kind of tossed a coin. If head comes, the kid gets a vaccine. If tail comes, the kid does not get a vaccine. Okay, and hence this random allotment makes the groups more or less homogeneous. Okay, and wait, there is one more factor coming in picture. Of course, now you might have your own concerns that some parents consented but still their kids did not receive vaccine. Is it, I mean, it is not ideal, right? Because they consented, they wanted a vaccine and they did not get. So it is kind of cruel against them. But yes, such ethical considerations will always be a problem in clinical trials. But for anyway, the safety of the vaccine, I mean, the efficacy of the vaccine was not yet established, so you have to go through such studies. Now, as I said, there is other thing. See, here for polio, I mean, whether you know, I mean, whether you have received a vaccine or not would not really affect the chances of getting polio. But in general, in many drugs, it has been observed that just the fact that you are receiving a drug itself makes a person feel better. Okay, that is known as placebo effect. Okay, what is a placebo? Placebo is like something which is not a drug, but it is supposed to act like drug for you. So sometimes they give sugar pills or something like that. So just by the fact that you are doing that action of taking drug, you feel in your mind that okay, I am getting a drug, so I should start feeling better, and I actually start feeling better. That is known as placebo effect. So to remove that, to eliminate that effect, every time in a designed experiment, care needs to be taken. So that was exactly what they did here. In the control group, even though no vaccine was given, the participants did not know that they didn't receive a vaccine. Now obviously next question is, if I don't get injected, I would know that I was not injected. So what they did was, they did inject everyone, but the people from treatment group, they were injected with actual polio vaccine, whereas treatment from the control group, they were injected just with salt water. Okay, simply salt water. Simply salt water was given as a vaccine here to these people, and these people were given the actual vaccine, and nobody knew who has received what. So that is known as double blind experiment. Why double blind? The patient did not know whether they have received a treatment or just a salt thing, salt water, and the doctors also did not know whether they are giving an actual injection or a salt water injection. The packing was same. So that's why it is called as double blind experiment. So why the patient shouldn't know is obvious, because the patient's response might get affected. But why should the doctor also not know? See, what happens is, sometimes the doctor is going to report the symptoms. So the doctor may also get biased if he or she knows whether the person has received the drug or vaccine or not. So in the case of polio, there are some borderline cases. So uh, identifying or locating some strains of polio is really difficult. So there are some borderline cases where the doctor has to make his or her own judgment and decide whether it's a polio case or not. Now, if a doctor knew that, say, this particular kid has already taken a vaccine, and if the doctor is in favor of the vaccine, then the doctor is more likely to say that this is not polio, this is something else, because you have already received a vaccine. On the other hand, if the doctor is against the vaccine, he or she is going to say, no, no, this is polio. You may have taken the vaccine, but it seems it has not affected, I mean, it has not reduced your chances of getting a polio. So the doctor may have their own bias in their mind. To remove that, this is a double blind experiment. So doctors also don't know. Doctors know that this kid received an injection, but they don't know whether it was injection of salt water or whether it was injection of vaccine. And of course, no consent group is another group who did not consent, so they had their own rate. And now you can see here, as I said, the difference between treatment and control is pretty obvious. And you can also see that in the no consent group, the rate of occurrence is comparatively quite low compared to the control group. And as I said, this indicates the difference between the two groups, right? So these control group people were also those who had consented to receiving the vaccine. So these treatment plus control, everyone is likely to have come from upper income group, whereas this is from probably lower income group. So their rate of occurrence is naturally lower than the upper income group with no vaccine. Okay, so that's why it when you are designing an experiment, you have to make sure that you choose your control and treatment group wisely. You make sure that they more or less match with each other, they are more or less homogeneous, they differ only on that factor, whether they are receiving the treatment or whether they are not receiving the treatment. By the way, when I say treatment, it doesn't have to be a medical treatment, it could be anything. Okay, so this this is a designed experiment. So here you chose people and then you did something with them. So you chose who are going to receive vaccine, who are going to receive, you means either you or the algorithm which chooses randomly, but this is a designed experiment. So you decide the sample size in advance. So you decide that okay, I am going to contact 1 lakh people and ask them whether they want a vaccine or not, and then proceed. But there are some things called as observational studies. So in observational studies, you may not get to choose, so you just observe whatever is already happening. Okay, and from that also you need to conclude something. Now in such cases, you will have a very less control on the design. Okay, so for example, uh, if you decide to see how many birds visit a particular tree of each species, whatever species you are interested in. Now, here you cannot really choose how many birds will come in each time. You will just keep on observing for a certain duration, say 1 week, and then whatever birds visit, you keep record of them. So, in observational studies, you have very less control on your experimental design. So, things are even more complicated. So, you have to make sure that no other factors are in play. So, you have to make sure that your effect that you are observing is purely due to the factor that you are studying. So, you have to do many rounds of observations to make sure that other effects are eliminated, confounding effects are eliminated. Okay. Whereas in a controlled experiment where you choose your sample in advance, where you choose your sample size in advance, things are comparatively better. Okay. So, are you now clear with all these terms? Bias, precision, control group, controlled experiment, observational studies, comparison, and of course confounding. Is everyone okay with all these
Yes, ma'am.
terms?
Yes, ma'am.
Yes, ma'am.
So now if asked, can you write, I mean, can you explain on your own what these terms mean? I mean, I'm not going to ask right now. I mean in exam.
Yes, ma'am.
Okay. So today we will stop here. Tomorrow we'll start with the next part. Okay.
Okay, ma'am.